Goes. Hello, I'm Timothy Priscilla with my Math 1314 class, and today we're going to talk a little bit about operations on functions. This is homework number 11 for y'all. Operations on functions. When you think about operations, we know the operations addition, subtraction, multiplication, and division on real numbers. Those operations can be extended to functions, and it's just the algebraic addition, subtraction, multiplication, and division. It's not anything new there. So addition, subtraction, multiplication, and division, it's the same as any algebraic operation. When you're adding and subtracting, that's just combining like terms. And when you're multiplying, that's just algebraic multiplication. Now, if it's two binomials, you'll wind up foiling. If it's a trinomial times a binomial, wind up distributing and combining like terms. But multiplication of functions is just the regular algebraic multiplication. Same thing's true for division of functions. It's just the regular algebraic multiplication. And to illustrate, I have an example here for you. This is problem number 1 in your homework. And we have two functions, f of x equals 4x plus 5 and g of x equals 2x minus 7. They want us to find f plus g, f minus g, f times g, and f divided by g. They also want us to give the domain of each. I'll find the sum, difference, product, and quotient, and then I'll worry about the domain of the functions. And I write large, so I'm going to move over here. Let me write this problem down. This is like your number 1 in your homework. F of x is equal to 4x plus 5, and g of x is equal to 2x minus 7. And first thing we want to do, find f plus g in terms of x. F plus g of x is just f of x, 4x plus 5, and I'll put it in parentheses just to indicate those terms came from f of x, plus g of x, 2x minus 7. And before I came in this class today, if you had had to add 4x plus 5 and 2x minus 7, you would have known what to do. The first set of parentheses are unnecessary. Nothing in front to distribute. The second set, preceded by that plus sign, nothing to do there. Those parentheses are unnecessary. You can just drop them. And so what's that going to give us for my final answer? Just combine the x terms, so 6x and 5 minus 7, I agree, with a minus 2 for 6x minus 2. You see what I mean when I said that it's just combining like terms? Addition and subtraction is nothing new. It's just combining like terms. Let's do f minus g. You take f of x, 4x plus 5, and subtract g of x, 2x minus 7, and the first set of parentheses, is there anything in front to distribute? No, so it's an unnecessary set. But before we came to class today, if I'd asked you, what did we do here? We have a set of parentheses with a minus in front. You could have told me. What do we do? Distribute through. What impact will that have? It's just going to change the signs. That's an assumed positive 2x. That's an assumed positive 2x and a minus 7. So it's going to become a minus 2x and a plus 7. And now it's just combining like terms. 4x minus 2x gives me a 2x. 5 plus 7 gives me a 12 for my final answer just of 2x plus 12. Any questions there? F times G. I said multiplication is just the same as algebraic multiplication. So we want F times G. That means you take f of x, 4x plus 5, and you multiply it by g of x, 2x minus 7. Before you came to class today, if I'd given you that and told you to multiply, you knew what to do. It's the same old, plain old algebraic multiplication. Looks like a binomial times a binomial, so we're going to 4-letter word starting with an F. FOIL it out. First, outer, minus 28x, inner, plus 10x, last, to give us an 8x squared, negative 28x plus 10x, that's a minus 18x, minus 35. And finally, f divided by g. F divided by g. F divided by g. This is amazingly the easiest one there is. We're performing the division using a fraction. F of x is our numerator, 4x plus 5. G of x is our denominator, 2x minus 7. Can we factor the numerator? No. Can we factor the denominator? No. That means we can't reduce it. There it is. 4x plus 5 over 2x minus 7. The sum, now they want the domains. The sum, difference, and products all have the same domains. First of all, what's the domain of f of x? The domain and range, they're both the same thing for f of x and g of x. They're slanted lines. So what are their domains? All real numbers. Remember, what did I say? If your function has no square roots and no fractions, what do you assume the domain usually is? All real numbers, negative infinity to infinity. Look, as you went through the work, did you pick up any fractions on just the first three? The sum, let me move it down. There, okay. Just on those. Did you pick up any fractions? Did you pick up any square roots? No. So the domain for the sum, difference, and product, they all have the same domain, and those domains are all negative infinity to infinity. The first three all have the domain negative infinity to infinity. Now the quotient, that domain's not going to be all real numbers. What will that domain be? What do we not want to have happen there? We have a fraction bar. We don't want that denominator to be 0. So finding the domain of this one, we'd say 2x minus 7 can't equal 0. That means x can't equal 7 halves. And you're going to have to type that in using interval notation like we did in the homework 1 week ago, so when we were finding domains. How are we going to type that in? We're saying x can be anything except for 7 halves. Okay, negative infinity to 7 halves. What's going to go after the 7 halves? Parenthesis, you don't want to include it, or this is saying all the numbers to the left is 7 halves. How do we say all the numbers to the right is 7 halves? Parentheses, 7 halves to infinity. Good. Any questions there? An important application of the composition of functions is the difference quotient. So I want to look at an example of the difference quotient. And before I look at an example, let me tell you what the difference quotient is. The difference quotient has its origins in differential calculus. It's an important component in the definition of derivative. For our purposes, it's just a quotient that you evaluate, okay? But if you have to take a calculus class, you're going to see more of it. And the difference quotient is defined to be f of x plus h minus f of x all divided by h. And I have a problem here I want to do. Involving the difference quotient. We have the function f of x equals 2x plus 5. Let's see here. F of x is equal to 2x plus 5, and there are 3 parts. They want us to find f of x plus h, and then find f of x plus h minus f of x, and then they ask for f of x plus h minus f of x all divided by h. So there are 3 parts. I think I'll do it right here. I think I'll do it right here on this page. Let me see something. Let's see. Is that better? Yeah, you can see it better? Okay, so here goes. First of all, we have f of x is equal to x squared plus 5. Part A, they ask us to find f of x plus h. That's saying go to the function f and replace any variable you see with the self in the parentheses, that x plus h. So we come up here to f, and we're going to replace that 1x with the blue x plus h. And now it's a matter of simplifying this. How do we simplify x plus h squared plus 5? How do we square a binomial? How do we square x plus h? We're going to write it twice and FOIL it out. We're not going to say it's just x squared plus h squared. And you know something? Anytime you have a function with a square, you're going to wind up with, and you're finding a difference quotient, you're going to wind up FOILing out that x plus h times x plus h. So it might be a good idea. I'm going to go to my scratch paper. Here's my scratch paper right up here at the top. I'm going to write that x plus h times x plus h. Let's FOIL that out because we're going to need it for this problem and the next one. So FOILing that out first. X squared. Outer is x times h. I'm going to write the letters in alphabetical order. Just for consistency, if I have 2 different letters in the term, I'm going to write it in alphabetical order. So an h times x. Inner, another h times x. Last, an h squared. So if we combine those terms, x plus h times x plus h, we're going to get an x squared. Let's see, where can I write it? I'll just write it down here with the problem. X plus h squared became x squared plus hx plus hx is 2hx plus, what else do we have? The h squared, and then that plus 5. So here's the answer to part A, f of x plus h. And it might be a good idea for you just to commit to memory x squared plus 2hx plus h squared. If you don't want to have to FOIL out that x plus h times x plus h each time, you might want to just commit that x squared plus 2hx plus h squared to memory. Now part B. Part B. Part B you can do without showing any work if you understand what they're asking for. They want you to take f of x plus h, the thing you just found in part A, and subtract off the original terms. Take what you just found here and subtract off the original terms. You can do this without showing any work if you understand what they're asking for. Take that, what you found, subtract off the original terms. Which terms are being subtracted off? But okay, so we lose the x squared and the x squared, 5 and 5. Here's a hint. In this event, all you should have left are the terms containing the letter h. You have a 2hx plus an h squared. And there's the answer for part B. And finally, part C. They want us to find f of x plus h minus f of x all over h. Let me move that up. F of x plus h minus f of x, that numerator is what we just found there in part B. So really they're saying take part B, the answer you have in part B, 2hx plus h squared, and divide it by h. Well, let's see. We have a common factor of h in the numerator, and that should always happen with polynomial functions, because in part B, once you perform that subtraction, the only thing left will be the terms containing h. So every term should have an h in its numerator. Factor out the h. When I factor out that h, what have I got left in the parentheses? 2x plus h, I agree. Cancel the h. There's our final answer, just a 2x plus h. Any questions there?